Okay, here we have a block on a slope. It's at a 30-degree slope. And we have a box that weighs 100 pounds. And what we're trying to do now is to determine what force is necessary to push this block up the slope. So it has to overcome two things. It has to overcome the weight of the block, pushing against gravity towards F, and it has to overcome friction. So for this problem, one of the things we want to do is to set up a coordinate system that is in line with the block. So we've got a coordinate system here. We've got y and x now aligned with that. And what we want to do next is we want to break up the forces in their components, in their x and y components. And the other one we really have to do that with, in this case, would be the weight of the block, okay? Because the force being acted upon to move it is in the x direction. And of course, the neutral force is going to be perpendicular to the block, so that's in the y. And the friction force is going to be in the negative x direction, and it's going to be, so we don't have to worry about that. So the other one, again, we'll now break up the magnitudes of the weights into their x and y components. And because it's at 30 degrees, we get 86.6 in the y direction in negative, and we also get a 50 pounds in the x direction negative. So then we can use this information to calculate what the force normal is. So if we do the summation of the forces in the y direction, we know that the normal force is equal to that y component of the weight, which is 86.6, and that also allows us to calculate the friction force, which is 34.6. Okay, that's just simply multiplying the static coefficient, 0.4, times the 86.6, and we get 34.64. Now, what we're trying to get is, what is that force F? Well, for this, we're going to use the summation of forces in the y, and the only two forces we have are the y component of the weight, which is 50, negative, and the friction, which is the 34.64. So those combined will result in that friction, or that force being applied to the blocks to push it up the slope, is 84.64.